Hi students, in this lesson we're going to simplify rational expressions and this is section 6.1. And a rational number is the ratio of two integers. So when you refer to ratio or rational, we're really talking about the operation of division. So let's talk about some of the properties you may already know. First, a over negative b. A lot of students don't know that a over negative b is the same as negative a over b, because both of these fractions are considered to be negative, for example. So that's why they're the same. And also you can see that negative right beside that line. So all of these are equivalent to each other in number one. So again, all of these are negative fractions and they are all equivalent to each other. Now, one thing I want to point out is that we normally will write our negatives in the numerator or on the side. So if you see a negative in the denominator, like so, if you see this negative in the denominator, always move it up to the numerator or the side of the fraction bar. Moving on to number 2, what is negative a divided by negative b the same thing as? So if you said a over b, you are correct, because a negative divided by a negative is positive. All right, moving on. A times k over b times k. Now, in class, I normally ask, what is that the same thing as? A times k over b times k. And I get a lot of random answers. I even get k times a over k times b. And that's the same, but there is a simpler way you could write a times k over b times k. A lot of times they don't realize that you can cancel out the k's because they are common factors. Because k divided by k is 1, correct? So you could cancel the k's out because k divided by k is 1. So the final answer is a over b. Now what about over here, a plus k over b plus k? Now can you cancel out the k's in this case? Actually, no, you cannot cancel out the k's. So you cannot cancel out the k's if you have terms. So here is something that you probably need to definitely write down. You cannot cancel terms. You cannot cancel terms. You can only cancel common factors. So that's why we were able to cancel the k's over here, because notice that they're factors. And what do I mean about factors? Factors are associated with multiplication. All right, terms are associated with addition and subtraction. So over here, these are considered to be terms, not factors, because it's, as you can see, there's a plus sign in the middle. Let's move on to a type of problem that says identify all values of a variable for which a rational expression is undefined. So that seems like a very complicated statement, but what it really means is to find the values of x that make the rational expression undefined. All you have to do is set the denominator equal to 0 and solve for x. So let's say this is number 1 and this is number 2. And we want to identify the values of a variable for which a rational expression is undefined. Well, what makes something undefined in math? When the denominator is equal to 0. So what we can do to figure out what x value will make the denominator 0, all you have to do is set the denominator to 0 and solve for x. Now we know the steps of solving equations from the last chapter. The steps are to put everything on one side, and that's already done for you. And then you will factor. You will factor this trinomial. Okay, no GCF, so, and it's the easy case. So I'm going ahead. I know it's going to be 3 and 1. I know that because that's -2. My 3 is going to have to be negative. So always check your factors. Make sure when you FOIL this out, you get x squared minus 2x minus 3, of course. But I can look at it and tell that it works. Now, the third step of solving equations with factoring is to set each factor to 0. So I'm going to do that. And also you solve for x. So you'll subtract 1 on this side and you'll get x equals -1. And then you'll add 3 on this side to get x equals 3. So what values will make this rational expression undefined? It will be -1 and +3. So what that's saying is if we replace the x's in the denominator with either one of these answers, we would get undefined, meaning that the denominator would end up equaling 0. And you can always test that by plugging in a -1 squared into the x's, right? For example, if we replace all of the x's with a -1, then we get +1 plus 2 minus 3. 3 minus 3 is 0. So all that's saying is these two values are the only two values that if we make that substitution to x, our denominator becomes 0. And normally we don't like that in math when our denominator is a 0. So moving on to the next problem, 2x squared plus 1 over 3x squared plus x. What values will make this rational expression undefined? So I'm going to erase this and we're going to do what again to figure that out. So look at the highlighted instructions. We're going to set the denominator equal to 0. So 3x squared this time plus x equals 0. And since our degree is 2, we're going to use factoring here. So we're going to take out the GCF, which is x. And if we take out that x, we get 3x plus 1 equals 0. So we have two factors. We set each factor to 0. One solution is 0, and the other solution, if we subtract 1, we get 3x equals -1 divided by 3, x equals -1/3. So these are the two values that would make the rational expression undefined if we plug those two particular numbers in the rational expression. Now we're going to move on to something that calls for us to use that technique that we just used to figure out what is the domain of a rational expression or a rational function. Now here I say rational function, so let's just say this was f of x here. I just made it into a function, okay? So let's say they are functions, and I want to find the domain of the first rational function. Well, we're just going to take the answers that we received from number 1, and those values were -1 and +3. So for number 1, the domain is, I'm going to put domain, all real numbers except x equals -1 or x equals 3. Now that's one way of writing the domain. There's also interval notation. Interval notation would be everything will work between -infinity to -1 union -1 to +3 parenthesis union 3 to infinity. So if you are familiar with interval notation from middle school or high school, that's how that would look if you wrote in interval notation. But I'm fine with you just writing out all real numbers except x equals -1 or x equals 3. Now for the second one, if we wrote it out, the domain would be all real numbers. And you have to put that all real numbers on it if you want to write it out. All real numbers except, and our answers are here, equals 0 or x equals negative 1/3. All right. Okay, moving on. A fraction is in simplest form when the numerator and denominator have no common factors other than 1. So you're familiar with simplifying something as simple as 10/30 because 10 is the common factor. So again, you can cancel common factors out, but you can't cancel common terms. So the common factor here would be 10. So normally we just divide in our head. So 10 divided to 10 is 1. 10 divided to 30 is 3. So it simplifies to 1/3. And you can try all of these by pause the video, try them, and then you can see the answers when I explain it. Okay, the next one, 56/49. Well, 7 is a common factor. So 7 goes in 56 8 times and into 49 7 times. 8/7. You do not have to write this as a mixed number. Keep it as an improper fraction. Okay, 36/24. So the common factor is 12. So we can divide into 36 3 times and 24 2 times. So our answer is -3/2. So don't forget about that negative on the side here. Then you have 72/-90. And most people will go for the 9, the common factor of 9 first. And that's perfectly fine as well. So if you did go for 9 first, then 9 goes to 72 8 times and then into 90 10 times. But here's what I want you to see. See how that negative is in the denominator? Please move that up. All right. But I'm hoping you will also notice that it's not reduced. It's not reduced all the way down. So really it ends up being -4/5 because 8 and 10 have 2 in common. So the final answer is -4/5. So because we simplified this twice, I know now that there was a higher number than 9 that could have divided into 72 and 90, right? So we used 9 first and then we used 2. So apparently 18 can go into both. Now, a question to consider. What is the difference? What is the difference between the following two algebra scenarios? Well, hopefully you've learned so far that a situation like this, we cannot cancel anything out. We cannot cancel common factors out. But over here to the right, however, we can cancel out these x's, and we have 3/6, which reduces to 1/2. So 1 can't cancel terms, but over here can cancel common factors. All right, let's go to the next level, which is something that looks like this: 15xy/25y. Now we reduce the numbers the same, right? Because we know that 5 can go into 15 3 times and 25 5 times. And of course, y's can cancel. So our final answer there is 3x/5. So again, pause the video, see if you can work these out and get the right answers before I explain. So we have 18/45. Definitely 9 can go in both of those. So 2 here, 5. But notice we have a common factor of a, top and bottom. So that's going to leave us with 1a in the numerator, but no a's in the denominator. So we have 2a over 5b for that one. Next, we have definitely this negative over negative is going to be positive. So we don't have to worry about that. But 14 actually can divide into 56 4 times. And you didn't have to choose 14, but you would see if you chose something else like 7 that you would have to keep simplifying. Also, we can get rid of y squared from top and bottom, leaving us with 1y in the numerator, right? And nothing else is in the numerator but 1y or y. And then we have a 4x in the denominator. Next, you have 54c squared d over negative 78c d squared. So I already know I'm going to have a negative. This is a negative fraction, right? And I also know that 6 can divide into both of these numbers. So that'll be 6 goes to 54 9 times, 6 goes into 78 13 times. And then a c cancels out top and bottom, but notice that there will be no c left in the denominator. And a d cancels out top and bottom, but notice this time that the d cancels totally from the denominator and is left in the numerator. So you have negative 9c over 13d. Now, what have you learned? You learned that you can cancel out common factors, but you cannot cancel out common terms. So when we go to the next level here, when you see something like this, x squared minus 4x over x squared minus 16, do you think we can cancel the x squares? Do you think we can cancel the 4 over 16 that's here? Well, no, you can't, because these are terms and you can't cancel terms. You can only cancel factors. Again, these are terms because they're separated by a minus sign. So we can't cancel this. So we can't simplify the following rational expressions by canceling terms. What we should do first is factor. So what we're going to do is factor the numerator first. Then we're going to turn around and factor the denominator. So how do you factor x squared minus 4x? So let me help you. That's not a difference of squares. So I see every semester I have someone to say that's a difference of squares, but it's not. Okay, so the first thing you're supposed to do is take out the GCF, which is x. And if you take out that GCF, you're going to be left with the other factor of x minus 4. Now the denominator is actually a difference of squares because 16 is a perfect square and x squared is a perfect square. So you would have x plus 4 and x minus 4. Now what we did was we just turned this into factors because x times x minus 4 are factors because that's multiplication. X plus 4 times x minus 4 are factors because that's also multiplication. So now we can cancel out the common factors of x minus 4, which leaves us with x over x plus 4. And we're going to move on to the next problem. We have x squared minus 4 over x squared minus 2x minus 8. So this is going to be a great way for you to practice your factoring techniques. So what I want you to do is pause the video, factor the numerator, factor the denominator, and cancel out common factors. All right. I'm going to proceed. Hopefully you pause the video and you have your answers. So here we go. X binomials, the leading coefficient is 1. There's no GCFs, so this should be pretty simple. We're looking for factors of 20, right? So I'm thinking x plus 4, x plus 5, because 4 plus 5 gives us the 9. And then in the denominator, again, I know that it's going to be x and x. Factors of negative 15 that adds to 2. So we know that positive 5 and negative 3 will give us that positive 2 in the middle. So again, we cancel out our common factors and we get x plus 4 divided by x minus 3. Moving on to E, x cubed plus 8. Were you able to classify x cubed plus 8? Now notice that there is no GCF, but you have cubes. So if you look at this, we could rewrite that as something cubed plus something cubed. And because of that, because we get x cubed for x cubed and 2 cubed for 8, we know that x would be our A and 2 would be our B in this formula. A cubed plus B cubed equals A plus B times A squared minus AB plus B squared. So the factors would be, instead of an A, we're going to put x. So we have x plus, instead of a B, right, we're going to put that 2. All right, so x plus 2 times a squared would be x squared minus 2x plus 2 squared, which is 4. And of course, x plus 2 is already simplified as much as possible. So the x plus 2's will cancel here, and our final answer would just be x squared minus 2x plus 4. And that is not factorable or anything, so there's no need to do anything to that. Moving on to F, it looks like we have a GCF, and what is it? Definitely a 6 is showing up in both x and y. So 6xy is our greatest common factor. If you take out 6xy, what times 6xy would give us back 6x cubed y? It would be x squared and then minus 1. Now it looks like we have a difference of squares, so we're actually not done factoring. Now in denominator, we have a GCF. Please do not ignore this x to the far right. All right, so that changes the situation. We must take this x out first before we deal with anything concerning trinomials. So we have x times x squared plus 5x plus 4, and we're going to factor completely. In the numerator, we have 6xy times x plus 1 times x minus 1. In the denominator, we have an easy case trinomial. We have 4 factors of 4 that gives us 5. Will be 4 and 1 plus plus. And what do we have in common here? Definitely an x plus 1 is in common, but can you see another common factor? Well, believe it or not, we can cancel the x's because all of this is multiplication here. So we can cancel those x's out as well. So our final answer is 6y times x minus 1 over x plus 4. Next, G, we have 2y squared plus 2. Definitely a common factor, GCF of 2. So we take that out, we get y squared plus 1. Now notice, we have y squared plus 1 here. That looks familiar. Can you classify that as a type of factoring situation? If you said sum of squares, you are correct. What do you know about a sum of squares, though? If you said that a sum of squares is not factorable, or if you said that a sum of squares is prime, then you are correct. Now let's move on to the denominator. We have 4 terms, which suggests that we need to group. I could take out a y squared from the first group, and it leaves me with y minus 5. Let's take out a positive 1. We'll also get y minus 5. So y minus 5 times y squared plus 1 are the final factors. And nice, we can get rid of the y squared plus 1, which leaves us with a 2 in the denominator over y minus 5. Alright, let's manipulate this problem x minus 5 over 5 minus x to see if we can simplify it. It can be simplified, and I'm going to show you how. Well, would you agree that this x minus 5 over 5 minus x is x minus 5 over negative x plus 5? I hope so, because notice that there's a negative in front of the x, and I put a negative in front of the x. Notice that this 5 has no sign, which means that it's plus 5, or is a positive 5. So here we go. X minus 5 divided by, in chapter 5, you were able to learn how to factor out negative 1. So if we factor out a negative 1 here from the denominator, we'll get negative 1 times x minus 5, right? So we just factor out that negative 1 so that we can simplify this expression. Notice that x minus 5 cancels out, and we're left with just a negative 1. All right? So these are called opposites of each other, so we are dividing opposites here. What I mean about that is opposites have different signs. So if you have a rational expression and you look at the numerator and it's totally different signs from the denominator, then you have opposites, you're dividing, and it will always equal negative 1, believe it or not. So again, dividing opposites, I mean that x minus 5 is the opposite of 5 minus x because the signs are all opposite each other. What I really mean is the signs, for example, x in the numerator is positive, but x in the denominator is negative, as well as, in addition to, the other term, right? It has to be all the terms. The signs must be different for all the terms. So notice that we have a negative 5 in the numerator, but a positive 5. So when that happens, when you're dividing that type of situation, your answer will always be negative 1. So if you know that, you really don't have to factor and do this little step right here. You just go straight to negative 1 as your solution. So you can remember that, it will save you a couple of steps. So let's go through this. Let's fill in the table. We're going to answer, are we dividing opposites? Yes or no? Can you simplify this further? And what does it simplify to? So let's get started. For the first one, are we dividing opposites here? If you say yes, then you are right. And therefore, can you simplify? Yes, because it simplifies to negative 1. Again, when you're dividing opposites, it will always equal negative 1. And I just proved that to you in this situation. So it'll be the same situation as H. Next, x plus 3 over 3 plus x. Are we dividing opposites? For this one, no, we're not. Because actually, x plus 3 over 3 plus x is the same, right? So can we simplify it? Well, yes. If this is the same, x plus 3, and now when I switch this in descending order, I get x plus 3, what simplifies to a positive 1. Next, are we dividing opposites? Yes. Again, if we're dividing opposites, it will simplify to negative 1. Yes for the next one. Because we have a negative, this really means negative parenthesis this. So if it means negative parenthesis this, then that means you have to distribute that negative to everything on your right. So really this is equivalent to, if I had to rewrite it, this is equivalent to negative x minus 4 over x plus 4. And notice that these signs are totally different from top and bottom. So they are opposites. And therefore, since they are opposites, it equals -1. Now, the last one, are we dividing opposites? No, we're not. No, we're not. And the reason is because, look, we have x squared and x squared. They are actually the same. So all of the signs have to be opposite of each other, top and from top. When you look at the top, the sign at the bottom has to be totally opposite from that. So, no. Can you simplify it? And you can try to simplify it. I was able to actually factor the numerator. I was able to factor that. If you wrote that as x squared minus 3x plus 2, I realized you can factor it as x, and you have -1 minus 2. That will work, but when I tried to factor the denominator, I couldn't do that. So we're going to say no to that, right? And for what does it simplify to? It doesn't simplify, right? Doesn't simplify. Now, one last problem for this lesson. Try simplifying the following. Try simplifying the following. X squared plus x minus 20 over 16 minus x squared. So this is a rational expression. We cannot cancel terms, so we factor. We have a trinomial, and it's an easy case, so I don't even have to do the AC method here. I have -20, and I want a 1 when I add, so I know it's going to be 5 and 4. I just got to figure out my signs. And since it's a positive 1, I'm going to make the 5 positive. And then we have 16 minus x squared. That is a difference of squares, because 16 and x squared are both perfect squares. So we're just going to write it backwards, because if you wrote it the other way, x plus 4, x minus 4, you would not get the correct signs for 16 minus x squared. Now, what do you notice here? You probably notice a couple things, but what I want you to notice is this x minus 4 and this 4 minus x. They look alike, correct? But are they exactly the same? They're not. And what are they called? They're called opposites. And what do we know about opposites? Do the opposites simplify? Yes, this part here that I'm circling is equivalent to what number? -1. -1. So yes, you can cancel this out, provided you replace it with a -1. So it'll be -1 times x plus 5 over 4 plus x. And of course, you don't have to write that 1. This is the same as negative parenthesis x plus 5. And if you want to write the denominator in descending order, which is what we normally do in math, we try to write everything in descending order, then x plus 4, you can write it as x plus 4. But it's not wrong. It's not wrong if you wrote it this way, but you probably more likely see it in this way. Okay, so I'm going to put or to suggest that if you put that one, it will be right. I would not mark it wrong. But you'll probably see it more like this in the textbook or anywhere else. All right, this concludes the lesson on simplifying rational expressions. I hope it helps you with the rest of the chapter.